Alright guys, this is a supplemental video on section 7 where we're looking at standard enthalpies of formation. So this is number 73 in your problem set. We'll go through letter A. You only have letter A and B to do for this problem, so doing letter A here is getting half the work done and hopefully clarifying the concept for you. So it says, using the values from Appendix C, calculate the standard enthalpy change for each of the following reactions. Now the full reaction that we're looking at for A is having 2 moles of sulfur dioxide gas reacting with O2 gas, producing 2 moles of SO3. So now we're looking for the delta H of this reaction. That's what the question's asking us. We can do this by looking at the enthalpies of formation given in Appendix C. And this is what I did in, this is what I was referencing in your video lecture number 28 for this section. So what we do is follow the formula given at the end of that video. It says the sum of your products essentially minus the sum of your reactants. Now this N and M here, those represent the coefficients in front of a product or reactant. That's all. Nothing too crazy. So that will reflect for your products, that'll be this 2 here, because we only have one product. For your reactant, it'll be this 2 here and the understood 1 in front of the O2. We'll make it red so they match. So to begin putting this together, I consult Appendix C. And since I didn't want to do that here in this video, I already put the information here to the top right. So the top right of the board here, I have all 3 substances that are in this problem. So I really just start filling in. So my products. My product is SO3. SO3's enthalpy of formation is negative 395.2 kilojoules per mole. Now, I'm going to multiply this by the coefficient in front of SO3, which is 2. Now, we know that coefficient means 2 moles. So if I put 2 moles there, moles cancel, leaving me with just the heat given off per 1 mole of, or in this case, per 2 moles of the SO3. That's your product side. Now I subtract from this your reactant side, which has 2 things. We have 2 moles of SO2. Now SO2 is negative 296.9 kilojoules per mole, and you've got 2 moles of it due to the balanced chemical equation, this 2 here. Okay, so moles and moles cancel, giving you just kilojoules. And now since you have another reactant, you would add the enthalpy of formation of that reactant. Now O2, according to the definition of what O2 is, it's an elemental molecule. So it's in its simplest form right now, thus it can't be formed, because the enthalpy of formation is the enthalpy required to form 1 mole of the compound. But since O2 isn't a compound and it isn't formed, it's naturally occurring on Earth, without being formed from other substances, it has an enthalpy of formation of 0. And that's in Appendix C, or just from now on, any element has an enthalpy of formation of 0. So no need to really put it, but I'll still just throw it there. We've got 1 mole of O2, that's 1 times 0 kilojoules per mole. And again, you could leave this part out. So I now simplify. I've got 2 moles times negative 395.2 minus 2 moles times negative 296.9. and I get negative 196.6 kilojoules. And that would be the heat of the reaction. So gentlemen, hopefully this helped. This is purely supplemental, just to help you conceptualize and understand the math behind the concept for enthalpies of formation, or standard enthalpies of formation. Peace.